Hello everyone. In this video clip, I want to discuss this Form 1 Chapter 3 Squares, Square Roots, Cubes and Cube Roots revision question. It's more on a summative practice to test whether how much you master this topic. So without further ado, let's start. Uh, by the way, whoever wants to take the quiz, you can click the link that I share at the description box. Welcome to try where your level is. Okay, so let's start by discussing the answer to the objective questions. Now, please do the quiz first before you watch this video. If you have done, now you can continue with my explanation on the solution of the questions given. So which of the following is a perfect square? Now, perfect square basically is the square of another whole number. So a square of any other whole number will always give us the positive number. So the whole number like 1, 2, 3, when we square it, it will produce the perfect square of 1, the perfect square of 4, and the perfect square of 9. And it will be good if you can memorize the perfect square table from 1 squared up to 20 squared, okay, which is 400. Okay, with this table, it will help you to solve a lot of perfect square question. So first of all, the negative is definitely out, and the perfect square if it is the square of another whole number, therefore any fraction will not be our answer. So the only answer will be D. Okay, now let's continue with question number 2. All right, for question number 2, we got to find the value of square of negative 0.4. So we can just ignore the ignore the decimal point for a while. Just look at the number 4. So after you square the 4, you got 16. And after we square the negative number, we got positive number. And then with this 1 decimal place, after we square it, it will become 2 decimal places. So we will have 1, 2. This is where we should place our decimal point. So the answer is 0.16. So A will be the choice of the answer. Now, or we can use the conversion between the decimal number and the fraction, because negative 0.4 can be written as negative 4 over 10. And we got to square this one. The square of this means the negative 4 over 10, okay, it's multiply itself twice. So negative times negative, we got positive, and 4 times 4 is 16, and 10 times 10 is 100. And this is the reason I said when we do the direct squares of a number, we can ignore the decimal point for a moment. Just look at 4. Okay, why? Because the 4 times 4 give us 16. And then the decimal places is contributed by the division of 10. Therefore, for 1 decimal place after we square, it will become 2 decimal places. It's because after we square the 10, we got 100 as our denominator. So isn't it the decimal places will become 2. So this is how we get the answer 0.16. So it's either you use the complete way or you can use the shortcut. Either way will give us the correct answer. So now let's move on to question number 3. For question number 3, we are given square root of 625 equals to 25. So we want to find the 25 squared. So from here and here, we can always apply the concept of equity that we have learned in, we can apply the relationship between the square and square root, because the square root is the reverse of square. That means if square root of 625 is 25, it means If we bring the square root across to the other side, it will become squared, 25 squared. And over here, the square root is already brought over. We're left with 625. Therefore, we got 25 squared equals to 625. So we can find the answer by relating this relation by identify the relationship between the square and square root. Okay, same thing applies to the cube and cube root. Yeah, so that is the answer for question number 3. Now next, we move on to question number 4. So for question number 4, which of the following is not a perfect square? Again, if you know the perfect square table, we do know that 1 is a perfect square because it's a square of 1. 121 is a perfect square because it's the square of 11. 160 is not in the perfect square table, so the C is the answer. Whereby 225 is the square of 15. So all of these can be easily solved if we can memorize the perfect square table, which is 1 square, 2 square, find out the perfect square all the way until 20 square. This table helps us to solve a lot of squares and square roots question. Okay, now let's move on to question number 5. Question number 5, it's cubic question. So be careful and read your question carefully. This is cubic question. That means negative 3 over 4, you multiply itself for another 2 times. Okay, so this will be the meaning of cubes. And let's settle the sign first. Negative times negative, we got positive. And then positive times with another negative, the final answer will be negative. So the answer which is not positive will not be our choice. So we left with B, C, and D. Now let's look at number 3. Look at the number of 3. So 3 times 3 times 3. So again, we have the cubic table to be memorized. We have 1 cube, 2 cube, 3 cube. Okay, 1 cube equals to 1. 2 cube is 8. 3 cube is 27. Okay, all the way until 10 cube, which is 1000. We just need to memorize up to 10 cube will do. Unlike the perfect square table, we memorize 1 squared all the way until 20 squared. But this one up to 10 cube will do. So 3 cube will be 27 and 4 cube is 64. Okay, build your cubic table and memorized it. It's very, very important. So 27 over 64, the answer is donkey. All right. Next, we move on to question number 6. Question number 6, it's a cubic, the cube root of a number. So if you memorize the cubic table, then this number is not difficult. Otherwise, you can use the calculator, no issue. Now, cubic of a negative number will always be negative. Since all these 3 are not negative, so the only answer is A. And by the way, 216 basically is the cubic of 6. And since we have 3 decimal places, okay, because this is a cubic, the cube, yeah? So 3 decimal places here, the original will be 1 decimal place. Okay, that will be, that is how we get from 3 decimal places, get back 1 decimal place. A is the answer. Okay, and next, let's move on to the next question, question number 7. Now for question number 7, we have to estimate. Now how do we estimate? We write the given number to the nearest perfect cubes that we know. So 11.4. Oh, so sorry, it's not cube. It's not cube root, it's cube. So 11.4, so we can round it off to 11 cube. All right, even though we can only memorize up to 10 cube, so this one we can count manually. So 11.4, gotta write like this, 11.4 cube. Okay, it's approximately near to 11 cube, all right, which is approximately equals to, now you see 11 squared is 121. So 11 cube basically is 11 squared times another times of 11. So 121 times 11. So we will have 121 plus another 121. Okay. So we have 1,331. So C is the answer. How do I get this? Actually, it's this 121 times 11. So 1 times 121, you get 121. Another time of 1 here will be another 121. So this is how I get 1,331. Okay, done with question number 7. Let us move on to question number 8. Now we have to calculate the value. All right. By the way, this is objective. You can always use the calculator. If this is in subjective, okay, take note of the working that I show here. So 2 squared minus cube root of 216. The 2 squared basically is 4, and the cube root of 216, and by looking at the number 216, if you memorize the perfect cube table, you will know that this is 6 cube. All right, so change the 216 into 6 cube, and then the cube root and the cube will be neutralized each other. So we have 4 minus 6. So the answer will be -2. A is our choice. Now, let's move on to question number 9. For question number 9, the problem solving. Okay, the area of a square field is 256 square meter. What is the distance in meter that Selina had walked if she walked around the field twice? So let's just draw the diagram of the field. It is in a square shape, okay, and the area given is 256. And we know that for a square, the side we can just use x to represent. So if from the given information, a equals to 256, by our own calculation, the a we can replace with x squared, which is equals to 256. Therefore, we can easily find our x. So 256 basically is 16. I mean, you bring your square across, it becomes the reverse of square, which is square root. So square root of 256 is 16. It's either you use the calculator and key in square root of 256, or based on the perfect square table, you know 256 basically is square of 16. Therefore, x is 16. And Selina walked around twice. So 1 time times 2. So isn't it she walked around the perimeter? Therefore, the total distance traveled, okay, total distance traveled will be twice of the perimeter of the square. Okay, and the perimeter will be 4 times the x, which is 16 here. So we have 2 times 64. Therefore, the answer is 128. D. Okay, so this is the solution for question number 9. Now let's move on to the last question. All right. Jeremy uses 6 pieces of rectangular cardboard with the length of 10 cm to build 4 cube-shaped boxes. Now we got rectangular cardboard, okay, and we have to build the square. So this cardboard, it says a rectangular. Oh, I think there must be a mistake here. I think this is a square. Yeah, because the Malay version is segi empat sama, yeah. So this is a square cardboard with the length of 10. And got 6 pieces of this. Now, these 6 pieces of square, if we join together, it will form a big cube, isn't it? So now with this, each pieces, all right, we need to form 4 cube shape. Therefore, isn't it, it will be easier if we divide each piece of cardboard into 4 equal parts. Let's cut it out. And therefore, this one will become 6 pieces, and each pieces will represent each surface of a cube. Therefore, we can find the volume of the small box. Yeah, the small box. So let's calculate. So 10, if we divide it by 2 parts, it will be 5 and 5. That means the new cube formed by the small cardboard will be 5 units. Therefore, the volume of this box will be 5 cube, which is 125. C is the answer. Okay, so that's it for the solution for the quiz. How many you got right? So you can just leave your score in the comment area, or should you have any other question, please also leave your question in the comment area. I come back to you as soon as possible. Thank you very much.